Hi everybody, Patrick here from EngineeringShop.com and ElectronicLessons.com. This kit is my pride and joy. It's the first kit that I ever designed. The initial PCB rev was not all that great and needed improvements, and I've made those improvements, and I've also added in a relay so you can control an actuator, you can control a solenoid and open and close locks if you like. It's very easy to use, and it comes with many options. So let's power it up and I can show you some of those options. We'll also do a demonstration of control using the relay at the end of the video. But right now I'll just give you the basic functionality and then we're going to put one together from scratch. First of all, let me talk about some of the ports. You got your power supply terminal block, V plus on the right, and negative on the left, your ground. That's your power supply. You can place anywhere between 7 volts to 20 volts DC. I suggest 7 volts to 15 volts DC because the 7805 5-volt regulator is not heat sinked. The circuit doesn't require a lot of power when the relay isn't on, but yeah, try to keep it between 7 volts and 9 volts DC. Your relay terminal block has 3 pins, and they're labeled on the board. Common, which is the middle pin, CO, NC, normally connected to common, and NO, normally open. We'll talk about that later when we do our demonstration of controlling AC using the relay. You've got a 2-pin header right here, which can be jumped using a little header block, and I'll talk about that when we get to the programming modes, because there's 2 programming modes. And then there are 6 pins right here. They are labeled as well. There is 5 volts on the left, then ground. This is a regulated 5 volts, so you can easily interface in any other digital circuit that you'd like, such as an arduino. So 5 volts ground, and then there's a tamper output, so anytime you enter in an incorrect character, the tamper output goes high. So you can use that, interface that with another microcontroller. And lastly, you've got your unlock. Now that unlock output goes high when the relay is on, during the unlock sequence. The last 2 pins are not used. They were put there because if a customer wants to buy a lot of these, I can offer those pins up to do certain things because they are connected to I/O ports of our microcontroller, which is a PIC18F1220. So we've got 2 programming modes. We've got pre-programmed mode and user program mode. User program mode is when the jumper head is not connected, and pre-programmed mode is when you have the jumper connected. So first of all, let's talk about user program mode. In the default program mode, user program mode, once you turn it on, power is applied, 10 volts at the input. What you can do is you can program in a 4-digit code. Let's do 10 9 8 5. Now when you enter in a character in, you can hold it down and it's entered in as soon as you let go. That red LED flashes in as an indicator, and once you've entered in entered in your user code, that green LED will flash, as you might have just noticed. So we've entered in our code. Now it's waiting for the exact same code. So let's type in 10 9 8 5. And when I let go of this button, the final character will be inputted into the system and the relay will turn on. You might have heard that click. As you can see, the green LED turned on, and the unlock pin here at the bottom is high right now. So when I press another button and let go of it, the relay turns off and it goes back into scanning mode, meaning it's waiting for us to input our code again. Now there's a timeout sequence as well. Let's try it out. Meaning if you take too long to enter in a code, something happens. Yeah, see, did you hear that beep? It says, oh, you're taking too long, hurry up. So again, let's just take our time. There you go. You have a very short period of time to enter in the correct code. Now what happens if you enter in the incorrect code? Beep, beep, beep. Incorrect code. As well, the tamper output goes high, so you can interface that with your microcontroller. Again, at the end of this video, after we've assembled one of these kits from scratch, I will hook this relay up to AC, such as a lamp, and we'll control a lamp with it. So let's try program B. In pre-program mode, the jumper is on during power up. On power up, the first thing the microprocessor does is looks to see if that jumper is there, connecting those two pins. So if you power it up and that jumper is there, the default code is 10 10 10 9. There you go, 10 10 10 9. Now I'll just show you this. I'll show you this again. If I turn the power off, I place that jumper there. It's already made the decision. It's pre-programmed mode. You can take that jumper off, and it won't matter. The code will still be 10 10 10 9. Same rules apply. The tamper output will go high when you enter an incorrect number. The unlock output will go high when you enter in the correct code, and there still is a timeout. Very easy to use. Very, very easy to use. Fun to put together. So let's put one together. This is what comes with the kit. 11 2K ohm resistors, 2 470 ohm resistors, 2 10K ohm resistors, 1 100K ohm resistor, a 1N4001 power diode, a 2N2222 NPN transistor, a red LED, a green LED. Note the green LED is green when it lights up, but it's clear in color. A 5-volt relay, a 100 microfarad electrolytic capacitor, a 0.1 microfarad ceramic capacitor, a 2-pin header, a 2-pin header connector, a programmed microcontroller, which is a PIC18F1220, an 18-pin DIB socket, a 2-pin terminal block, a 3-pin terminal block, a 7805 5-volt regulator, 10 monetary push switches, and a 5-volt piezo buzzer. So let's start with the resistors. They're all labeled on the board as either 2K, 100K, 10K, or 470 ohm. So since resistors have no polarity, just find where each of the resistors go on the board and solder them into place. Then we'll talk about some of the more complicated circuitry. With all of the resistors placed, we're going to worry about some of the components that don't have polarity. Right here there's a 2-pin header, and that goes into the JMPR slot, short for jumper. Make sure that the shorter pins go in first so that the longer pins are protruding from the board. You've got a 0.1 microfarad ceramic capacitor, and that goes into the C1 slot. It's labeled 0.1U. Since it's ceramic, there is no polarity. You can place it in either way, no problems. You've got 10 buttons, 10 monetary push buttons. There is they only really fit in one way. You should be able to pop them right in, no problem at all. And your 2 terminal blocks. Make sure that the screw ports, these are the screw ports, make sure that they're facing outwards for both of them, or else, because if you have them facing inwards, you're going to have problems. You're not going to be able to wire in your power supply wires, and you're not going to be able to wire anything up to the relay terminal block. So if I'm being ambiguous there, don't place it in this way. Make sure that the screw terminals are facing outwards. So let's solder those all into place, and then we'll worry about some of the components that have a polarity. Okay, now we're going to do our electrolytic capacitor, our power diode, our 2 LEDs, and our piezo buzzer. Now from this angle you can't see the piezo buzzer leads, so let me just, there we go. We have one short lead and one long lead. In fact, every component here except for this diode has a shorter lead and a long lead. In every case, the shorter lead is your negative, the longer lead is your positive lead. Now for the piezo buzzer, there is, on the footprint, there is a plus symbol on the upper side here, and that is an indicator that's the positive side. So place your longer lead in the pole with the plus sign beside it. The 100 microfarad electrolytic capacitor, on the bottom side here, there is a very small plus sign. Look for it. Place your longer lead in the hole with the plus sign beside it. Very important. Place that backwards. You might end up, you'll certainly harm the capacitor. It might even blow up depending on the voltages you have. They're very, 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 very important you place that in the right way. The diode, what you'll notice is on one side there is a white stripe, on the other side there is not. The white stripe is the negative indicator, or the cathode indicator, and the black side is the positive indicator. So on the footprint here, look for the diode right beside where the relay is supposed to be. There is a white line on one side, the bottom side. Make sure to line the white side of the capacitor, the side with the white line, to the white line on the footprint. Don't place that backwards, or else there will be a complete short circuit when your relay is activated. Very, very important. Your two LEDs. Notice there is a short lead and a long lead. The short lead is the cathode. The long lead is your positive anode. There are two LEDs right here. Now you probably can't see it, but the right side of the footprint is flat. The left side is curved. The curved side, or left side in this case, is your positive. Make sure you place the longer lead in the left holes and your shorter leads in the right holes. But again, if you ever see this footprint again, it may be hard to understand which is positive and negative, but if you actually look at an LED, you'll actually notice on the side with the shorter pin, there is a flat ridge on it, and that's supposed to indicate that that is the negative side. It's supposed to be a secondary indicator because sometimes people clip the LED leads. So remember, from this perspective, the right side is where you place your shorter leads, and the left side is where you place your longer leads. Now it's labeled red LED on top and green LED on the bottom. So let's solder all those into place, and then we'll solder in the regulator and the NPN transistor. Next we've got our regulator, our 5-volt regulator, 7805, and our 2N2222 NPN transistor. The 7805, don't place this in backwards. Notice the white backing here. Line that up with the white backing on the footprint here. Make sure that the white backing is facing the terminal block. When you solder it into place, make sure your solder joints are very strong, because if that's not connected, your circuit will not work. Your NPN transistor, right here, T1, it's labeled 2N2222. There is a flat side and a round side of the transistor, and on the footprint there is a flat side facing the relay and a round side facing the microchip footprint. Make sure that from a bird's eye view you match those up, or else the relay will not work. So again, the flat side of the transistor face the flat side from a bird's eye view of the footprint, and the curved side to the curved side closest to the footprint of the IC. Now the flat side of the transistor actually has the writing on it. It should say 2N2222. So solder those two into place. Next we'll do the socket and place our IC, and we'll do the relay, and then we'll do a demonstration. Alright, we're going to fit this into one last step. The PIC 18F1220 footprint has a notch on the left hand side. A notch in the footprint. Make sure that when you place your socket into the footprint that you match, the socket has a notch too. You want to make sure that the notch matches the notch on the footprint, because there's also a notch on the left hand side of the IC, and when you place that notch in, you have to make sure that it's facing left. However, once you place the socket in, you won't be able to see the footprint anymore, so you have to use the indicator on the socket as an indicator as to which direction to place the IC. So again, on the left hand side there's a notch. Place the socket in with the left hand side with the notch indicator. Then when you're ready, place the IC in with the notch to the left. The relay, very easy. It only fits in one way. There's 5 pins, 3 on one side, 2 on the other. You can only fit in one way. Make sure that your solder connections are very, you have place a healthy amount of solder there. You want that to be strong, because you're going to be using AC devices there. You're going to be powering some heavy duty stuff there. So make sure it's strong, strong, strong. Okay, that's it. We're just about done. We're going to solder this into place. We'll turn on a lamp or something. It is time to test our new combination lock. So power it up. Let's see if everything works. Our red LED works. Our green LED works. Our relay works. And our piezo buzzer works. Now, if you don't want to lose your header pinner, your header connector, so what I like to do is, if I'm using user program mode, I like to keep the left side of the header on one pin, or the header connector on one of the pins, so it's not actually making a connection, but then you won't lose it. So that's just a tip. So let's talk a little bit about how we have to interface this with AC. The common pin of the relay it's either connected to the NC pin or the NO pin. By default, if the relay is not activated, the common pin, the CO pin, is connected to the NC pin on the right here. It's so normally connected to common. NC stands for normally connected. When the relay is activated, the common switch pin is no longer connected to the normally connected switch. It's connected to the NO switch, which is normally open. So you just have to think, when the relay is off, the connection is here. When the relay is on, the connection is here. So what you want to do is, if you want to control AC, and don't control AC if you don't know what you're doing. Have someone supervise you or work with you who knows how to work with 120 volts AC, because it's dangerous stuff. But if you want to use it, what you do is you'll take an AC power cord to an appliance, cut the black wire in half while it's not plugged in, of course. Place one of the severed black wires in the common pin and the other severed black wire into the NO pin. So when the relay is activated, once you put the right code in, the relay turns on and it reconnects those wires internally through the relay. So I have a little setup. I've been using just my lamp as an example, because it is an AC device and it's nearby. So what I'll do is I will hook up my dollar store power bar, and I will turn on my lamp. As you can see, I've severed my black wire. That is live. It is dangerous. Keep your hands away from this area of the terminal block. There are 4 mounting holes on each side of the device, so you can mount this on a fixture, and if the holes are not big enough, they're far enough away from the circuitry that you can actually use a drill and make them bigger. You won't harm the board. So let's power on our device and enter in a code. Let's just do 0, 0, 0, 0. So now when I type in 0, 0, 0, 0, these 2 wires will be reconnected internally and the lamp will turn on. So let's just get a better view of what's going on. Okay, so the lamp on the right will turn on when I type in the code 0, 0, 0, 0. Pretty cool, huh? Now I'll press another button, any button. Relay turns off, and now it waits for me to put in the right code again. 0, 0, 0, 0. Relay on. It'll stay on until I tell it to turn off. Press a button, I'll type in the wrong code. Beep, 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 wrong code. Hope you like this, guys. Hope you'll visit my store at engineeringshock.com, and we can find our eBay store through electroniclessons.com. We've got tons of stuff, tons of new kits coming in the new year, RFID, voice recognition. Just check us out. Thanks for watching, everyone.